Hello, Keith Rucker here at VintageMachinery.org. Guys, today back to working on another project, a new project, and what we're going to be working on is making a gear. This is a very unusual gear, I guess you could say. It is a helical gear. I know a lot of people have been anxiously awaiting me cutting some helical gears over on my milling machine since I had my lead attachment put on there, and this is going to be an opportunity to do that. This gear is a timing gear that goes in an engine. This is the camshaft. This is the gear that goes up on there, and it's for the timing system on there. And this came out of, very interestingly, let me look at my notes, a 1928 Austin automobile. Now that's a British-made car. I don't really know much about it, and I'm kind of doing this for a friend of mine that is actually a friend of his, and it kind of ended up in my hands to see if I could recreate this part. So we're going to give it a shot. I think we can knock it out. It's going to be a fun little project, I think, and I think you guys will enjoy coming along for the ride. Let's go over here, kind of zoom you in and talk a little bit about what we did to get to the point where we're at now, ready to start machining, because there was a lot of work that had to take place before we could even start on this project, and I want to talk a little bit about that. So this is the gear in question that we need to reproduce, and as you can probably tell, this one is broken. It's in 3 pieces, or 4 pieces, 1, 2, 3, and then the hub is 4. Came to me that way. Don't know exactly what happened. It is made out of cast iron, and right now I've got it pieced back together and held together with the zip tie on there, which kind of helped me figure out the dimensions and all that kind of stuff to make this gear. It is made out of cast iron. And I know I get a lot of questions from people when I'm doing this kind of stuff, you know, what material should I make it out of? Well, I'm making it out of cast iron. And the reason I'm making it out of cast iron is the original was made out of cast iron. This is a restoration this gentleman's doing. And while nobody will probably ever see it, generally speaking, in the restoration world, you want things to be original as possible. So when I'm making a reproduction part, I don't try to re-engineer it. I don't try to redesign it. Unless you just absolutely have to, and there are circumstances where that may be the case, but in this case, this gear was designed to be in cast iron. It was probably designed to be in cast iron for a reason. I'm not going to second guess them. We're going to make it in cast iron. So, and to do that, I've actually had a casting done. We're going to talk about that in just a minute. So, I don't remember. I think it's a 30-tooth pattern. It's about a 45-degree angle on the gears there, and we're going to be cutting that over on the milling machine eventually. Now this thing has the hub in it, is a tapered hub, and he actually sent along the camshaft here that this fits up on, and you can see down here, this is where it fits. It's clearly tapered, so one size is larger than the other, but it fits up on there. You get a nice tapered fit. There is a key in there as well, and a nut to kind of hold it in place. So we're going to have to recreate all that over on the lathe from the castings. Now, when I was doing this, you know, kind of coming up, getting everything ready for this project, the first thing I did was I kind of drew the gear up, or at least the gear blank up in CAD. I used Fusion 360 and developed a pattern. And this is a pattern that we developed. It's a split pattern in 2 pieces that we could send to a foundry and have cast in cast iron. Yes, I could have just bought a piece of solid cast iron and machined all that out. But again, I'm a stickler for details. This was a casting. I thought it needed to be a casting. So we are going that route. This pattern, the split pattern, was sent to Clark Easterling over at Windy Hill Foundry, and he did my castings for me. And these were 3D printed. I 3D printed these on a resin 3D printer that I have that I use for making small patterns quite frequently. And it is oversized, and we're going to be machining a fair amount of metal off of this to get to it. I probably made it a little bit larger, a little bit more oversized than what would have been done at the factory or when they were making these gears, but the end of the story is at the end it's going to be the same dimensions as what we have over here, so that's not going to be an issue at all. One thing I'll note is on the original they had some lettering in here. It says Q2, and then you flip it upside down and you have the IA265. Those were the numbers in there. And since those were in the originals, hopefully you can see that, I put it into my model. I actually put those in there, and when this was cast, just like the original, the lettering came out. So as for the casting, that is the rough casting that we're going to be working with. Again, this was done by Clark Easterling at Windy Hill Foundry, who I do a lot of my foundry work with. You can see he does some pretty fine work, and the lettering came out very similar to the original. So I think that's a neat little thing to have that those original markings on there, just like the original was. So anyway, I'm pretty happy with that. This casting, we need to go over and start machining it, and I'm going to take it to the lathe. So I think the first thing I want to do is I want to get this taper set up on the compound on my lathe, because we're going to be boring that hole out, and it's just going to be easier to go ahead and get this set up now than machining it and then having to set this up and then go back to machining the hub. So I'm going to go ahead and do this right now. What I've got is the camshaft on here. It's set up between centers on the lathe, and I've got an indicator onto that taper. And what we'll be doing is we're going to be sweeping this back and forth on the compound, and we're going to be bumping that compound around until we get that running zero. Right now it's out a little bit, so I'm going to get got a little brass hammer here. I got this compound a little bit loose. So we'll go ahead and sweep it again. Still needs to come in some more. Still needs to come in some more. All right, let's try this. I think I got it pretty close. We're gonna go off with this. Now there is a little bit of wobble in the screw itself here on the lathe, but it's within half a thou on the wobble. I think we're fine. We're going to tighten that down, and we should have our taper set to bore that out. Getting ready to start actually machining on the casting here, and what I've done is I've got my 4-jaw chuck on here. I've got my jaws turned around. I'm gripping on the outside of this. And I've got this running as true as I can get it. I mean, this is a rough casting. I did put the indicator on this inside rim, trying to get it to run as true as I could, but you know, there's going to be 10,000ths play in there just because this is not a machine surface. But we got it running as true as I can get it. I'm going to start machining on this backside, because if you look at the original, they actually kind of machined an area here that is true on that casting, and then, you know, just enough to clean it up. And then there's a certain distance from that to this outside edge. I want to get that set, and then we'll flip it over and kind of do the same type of thing on the other side. So let's go ahead and get in here. And I think what I'm going to start with is just facing this inside piece. And I don't want to go too far. Let's see. Just kind of do it similar to the original. I'm going to go out to it's about right in there. It's really not a critical measurement. You can see the wear area here where it was up against the piece, but we want to go out a little bit past that just to make sure we have plenty of clearance. All right. We'll come in here, kind of go to that middle. Remember, the center is going to be cut out with the drill bit. And I'm actually cutting a little bit more than what the original is, but I think it'll be fine. That is all we need. It gives us a nice area in there in the middle. All right, the next thing I want to do is I want to just touch this outside rim a little bit, and then we'll get a measurement on that. I just want to get a good cleaned up surface. All right, it gives me something to work with here. It's not cleaned up completely, but enough to get a measurement. I measured on the original one, basically the distance between this surface and this surface. I'm going to use a depth micrometer to measure that. And we've got, it looks about 350 thousandths. And I'm going for 265. So we've got about 100 thousandths to take off of this outside edge. Let me put this measurement in my digital readout. All right, I put that measurement in there. It was 346 thousandths. I'm going to 265, but I can, now that I got that in there, just read off of my digital readout, and we'll just start facing that out. A little bit at a time. All right, this should be our final measurement. All right, let's see what we got here. All right, I think we're right where we want to be, 265. With that side faced off, we're gonna take this out of the 4-jaw chuck, and what I'm gonna do is I'm gonna turn it around, and we'll have that face side going back up against the jaw, so we should be able to kind of turn parallel to that. I want to make sure I don't have any chips or anything back behind that face. And I'm just going to lightly put that in there. Got my dial indicator here, and we're going to kind of come in on this hub. I think that's going to clear. And I want to get it running, that hub running true. And you can see we're out a good bit right now. It's like this one here's the worst. Needs to go in the other way. So we will loosen that up, come around the other side, tighten it up. Still needs some more. Was out a good bit. We'll get this one next. Loosen that one up. What I'm doing is I'm trying to take about half of that distance between the two. Okay, we'll zero that one. Go around the other way. Again, taking about half of that. I didn't quite get there. So I'll go back over here. Re-zero. Loosen it up a little bit. Now we're getting down pretty close here. And see what it looks like running. Looks good. All right, we got our part in here. It's running true. Everything looks good. The next step is I want to get this hub, the thickness of this hub, from that machine back face to this front face. to the same as the original, which is 7/8 of an inch. Now to measure that, I'm going to be using a hub micrometer, which is going to reach through the hole and measure it. But before I can do that, I need to just get a good surface here. Then we're going to have to drill the hole. Once we drill the hole, we'll come back and we'll finish getting that machine to the proper thickness. So let's just come in here and we're just going to lightly face this. I just need a good surface that I can measure off of. So we'll make a couple of passes and just get it cleaned up. That's all I'm after here, is just a cleaned up surface. And that is probably enough, but I want to totally clean it up, so much better. All right, we will pull that out and drill that hole in there. All right, we get our hole drill. We'll start with a center drill. Just lightly touch and give me a little dimple right there in the middle of the hole. All right, then we'll get us a pilot hole going through here, and to do that, I'm going to use this 3/8 inch drill bit. We'll drill that all the way through. Now I've got a 3/4 inch drill in here, and we'll just drill that all the way through. All right, so now we're going to come back in here and touch off again, just ever so slightly, and I'm going to reface that. This is just going to establish a 0 point. All right, so then this is a hub micrometer, and it allows us to reach up through that hole, kind of hook it on the back side, and I haven't even got enough to hook it yet, so I need to face some more off. Yeah, that's going to let us hook. So now I can come in here and measure that thickness, and it looks like we're just a little over an inch thick, almost exactly an inch thick. So I'm going to just put that number into my digital readout. 1.001. All right, and we are going to 875 on that. So I can just watch my digital readout until I get to 875. All right, this should be my final. Go nice and slow, get a good smooth surface. I'm going to come back across it. That hub micrometer in there one more time. Right on 875, right where we want to be. All right, got that one done. Next I need to measure the thickness of this up here. Let me get a micrometer to do that with. So the last step here on the lathe right now is we need to get the thickness of this part up here where the gear is going to be to 5/8 of an inch. And the problem I've got is getting something back behind that in the chuck. I can't get all the way back. A micrometer won't fit. My hub micrometer won't fit. But I did dig around. I'm going to use this. It's called a groove micrometer. It's for measuring a groove. But I can hook that back side and I can hook the front side here and get a measurement. And I think it's going to be just fine to get what we need. So that's what we're going to use, and we got a good bit of metal to take off of there, so let's go ahead and start facing it. That's my starting point. So I'm gonna do is come in here and get a quick measurement on that, just to put in the DRO so I can kind of keep track of where I'm at. And looks like we're at, all right, we're at 875 plus 17. All right, looks like we're at about 892 thousandths right there. I'm going to put that in my digital readout, 0.892. There we go. We're going to 625. So we got a good bit of metal to take off, but I can keep a track of where we're at there on the DRO, and we'll get another measurement when we get down a little bit closer. All right, we're getting real close. Should be able to just dial in my 625 right there. Yeah, we're reading right on the money. There we go. That's perfect. So looks like my web on the inside is a little bit thicker than the original. Let me take a look at that. I might want to see if I want to machine a little bit of that metal out. Give me just a minute to look at that a little bit closer. So guys, I've gone back and done some measuring or whatever, and the thickness of this gear ended up being a little bit thicker than what the original was. And I think that what happened was my pattern just has this web probably about 200 thousandths thicker than the original. It's not a problem. It's only going to make this gear stronger. In fact, where the old gear failed was in this web. So we just made this thing extremely more strong than it used to be. Now, as far as any kind of clearance issue, where if this surface went in about 200 thousandths deeper up underneath this outside edge, I can't see any issue with that. So you know what, we're just gonna leave it alone. It's not gonna be exactly like the original. It's gonna be thicker in that web. But again, all we're doing is making it stronger. So everything else should be fine. So we're gonna leave it as it is and move on with the project. So the last operation in this setup is we need to bore out the hub at the taper. Remember, this was at a tapered angle, and we set the taper on the compound coming in and out, just using hand cranking on the compound back at the beginning of the video. So a couple of things to note here. First off, because of the way I set the angle on the compound, we're actually having to cut this on the back side rather than on the front side. Now, I did that on purpose because I've also got to make a mandrel to put this on. It's going to be easier to cut the mandrel with the compound going in this direction. So, but because we're going to be cutting on the back side of it, I have a left-hand boring bar in here, and we'll be turning the lathe in reverse. Normally the lathe is turning towards me. In this operation, we'll be turning the lathe away from me so that it's cutting on the back side there. Thought I'd point that out. The other thing is I'm going to start and we will get a measurement on that diameter, and I can go back to kind of the zero by getting my carriage back to the same place. So I'm going to zero my carriage out on the digital readout so I can move it backwards to get a measurement, then come back in, and I should be in the exact same place that I was before by using that digital readout. So let's get started. We'll fire this lathe up in reverse, and we'll come in here and get a surface started on that taper. All right, so what I'm going to do now, again, I've got my carriage zeroed. I'm just going to move everything back, and I'm going to come in here with just a pair of calipers, and I just want to get that diameter roughly right there at the opening. and it is 775. I'm gonna put that in my digital readout. Here and get another measurement. And I'm gonna go, it should be leaving about 5 thousandths in there. But I really want to sneak up on this number, so again, we're going to do a test fit here, or a measurement rather, and then probably a test fit too. Let's see where we're at. So I'm still about 5 thousandths from the original measurement. So what I'm going to do here now is I'm going to do a test fit. This is the camshaft, and it's going to fit up on this taper right here. And that taper, I mean, it feels really good. I think we got the taper mash. And there was kind of a mark where it was at that it goes up to, and I do need to go just a little bit deeper. So we're going to take a really light, about a 5 thousandths cut in there, and I think we'll be right to where we want to be. So that's my 0. I'm going to go in about 4 or 5 thou. This just barely fuzzing. This should be my final pass. Going nice and slow. Yeah, that's right to the original line. And that's a nice tight fit. I'm happy with that. I think we got our bore done. All right. Guys, I'm running out of time in the shop for today. I've still got some more work to do to this before we're ready to go to the milling machine. And like I just mentioned, the first thing I got to do is make a tapered mandrel that this gear will fit up on, that we can then go over to the lathe and turn it. So we basically will have a mandrel that spins, that this we fix to, and we can turn the outside diameter true to the bore, and then we can also use that to cut the gears over on the milling machine. So the other thing we got to do is we've got this key that's in here, and we'll broach that just like we broach anything else. And normally when you're broaching, you use a little collar like this, you drop down in there, and that guides the broach to make your hole. But because we have a taper here that going through there, it's larger on one side than the other, things wobbling around, it doesn't fit. So what I'm gonna have to do is make a little piece here to guide the broach that is tapered. And I mean, this is obviously way too big, but you can kind of see this is one that I had in my collection that came from somewhere, who knows where, but it's for a tapered bore. So we'll set that up over on the lathe. We'll make a plug to go stand in there, go to the mill, put the slot in there for, it'll be a slot more that size, but we need to make a custom broach collar to broach this with. Now the angle is already set up over there on the lathe, on the cross slide, just like we bored. That's the reason I set it up where we were having to do it on the back side, so that when we're turning, it'll be on the front side and be the right angle. And we'll have to make both of those parts before we tear that lathe down to do anything else. So that'll be coming up in an upcoming video. And then obviously too, we'll be cutting the spiral gears, which is something I've never done before. My machine is set up to do it, or can be set up to do it. So, we'll have a little adventure there. Hopefully all will go well. and we won't have any issues and have to make a new part. I think I've already kind of talked about, this thickness here. Obviously that web is a lot thicker than the original. Not a problem. It looks a little bit different. We don't have as much of an inset there, but as far as I can tell, there's nothing needed in there from a clearance standpoint. So this is only going to be stronger, so I don't have a problem with that. If need be, we could come in there with a tool and cut some of that out, but again, I just don't see the need to do it, so we're going to leave it like it is. All right, so I think we've made good progress on our gear, timing gear for this early 1920s model Austin car. Well, there you go, guys. That is going to be a wrap. I hope you enjoyed watching a little bit of turning. Have to get a little bit creative sometimes with these projects, but we're getting everything knocked out and hopefully be cutting some gears here before too much longer. And with that is going to be a wrap. As always, thank you guys so much for watching. Please subscribe to the channel if you haven't already. Hit that bell icon up there. That'll get you notifications when new videos are posted, so you can keep up with what's going on here. Sometimes, even if you subscribe to the channel, YouTube doesn't do the best job in the world of telling you when I post a new video. But if you hit that bell icon, they should send you some type of notification and let you know. It's a little better than even subscribing. Also, big thank you out there to all my supporters who support the site through Patreon, through PayPal, by sending stuff in. We feature a lot of times in our odds and ends videos. Always very appreciative to all of that as well. And guys, with that, again, thanks for watching, and we'll catch you on the next video.